Welcome, students, to an exciting exploration of one of the most important concepts in economics, the price elasticity of demand. Now, we know that when the price of something goes up, people usually buy less of it, right? But have you ever thought about how much less? Is it a huge drop or just a little? That's exactly what price elasticity of demand, pronounced as price elasticity of demand, measures. It tells us how sensitive or responsive the quantity demanded of a good is when its price changes. Mathematically, price elasticity of demand is the ratio of the percentage change in quantity demanded divided by the percentage change in price. We can write it as ED equal the percentage change in demand for a good divided by percentage change in the price of that good. In simpler terms, if the price goes up by 10% and the quantity demanded falls by 20%, the elasticity will be 2, which means demand is very sensitive to price. Understanding this helps businesses decide whether to raise or lower prices and aids the government in making fiscal policies, such as deciding how taxes on goods will affect consumption. Before we move on, let me ask you, think about your favorite snack. If its price doubled tomorrow, do you think you'd stop buying it completely, buy much less, or keep buying as usual? Take 20 seconds to reflect on this question. This is your first step to thinking like an economist. Now that we've introduced what price elasticity of demand means, let's explore how we calculate it precisely. In the formula ED equals percentage change in quantity demanded divided by percentage change in price, the symbols delta Q and delta P refer to the absolute changes in quantity and price respectively. Let's break it down further. The percentage change in quantity demanded is calculated as the change in quantity, that is the new quantity minus the old quantity, divided by the old quantity, multiplied by 100 to convert it to a percentage. Similarly, the percentage change in price is the new price minus old price, divided by old price, multiplied by 100. One important point is that because of the law of demand, quantity demanded moves opposite to price, making elasticity negative. But for ease, economists talk about the absolute value, ignoring the minus sign. Think about this carefully. If a good's price rises by 20% and quantity demanded falls by 10%, the elasticity will be 0.5, a number less than 1, indicating demand is less responsive to price changes. Take a moment. Calculate in your mind. If a product's price increases by 25% and the quantity demanded drops by 50%, what would the price elasticity be? Pause for 15 seconds to think. Let's put theory into practice with a real example involving bananas, a common fruit many of you enjoy. Suppose you buy 15 bananas when the price is rupees, 5 each. Now imagine the price rises to rupees, 7 per banana, and you decide to buy only 12 bananas. This situation is illustrated in the table shown on the screen. Table 1. To find the price elasticity of demand, first calculate the percentage change in quantity demanded. The change is 12 minus 15 equals minus 3, divided by the initial quantity 15, then multiplied by 100. That gives negative 20%. Similarly, the percentage change in price is 7 minus 5 equals 2, divided by 5, multiplied by 100, equals 40%, 40%. Finally, elasticity is the absolute value of percentage quantity change divided by percentage price change, or 20 divided by 40, which equals 0.5. This tells us that the demand for bananas is not very sensitive to price changes. It is inelastic. Bananas are often seen as a necessity, so even as prices increase, people reduce quantity demanded only slightly. Pause and think. Can you think of other goods you buy with inelastic demand? For example, necessary medicines or basic food items. Reflect for 20 seconds before we proceed. It's crucial to understand the different types of demand elasticity as they help interpret consumer behavior and guide pricing strategies. When the absolute value of price elasticity of demand is greater than 1, we say demand is elastic. This means consumers are quite sensitive to price changes. A small change in price triggers a larger change in quantity demanded. Luxury goods and non-essential items often fall in this category. On the other hand, if the elasticity is less than 1, demand is inelastic. Consumers don't change their buying habits drastically, even if prices fluctuate. Essential items like food staples and medicines often exhibit inelastic demand. When elasticity equals exactly 1, it's called unitary elastic demand. Here, the percentage change in quantity demanded is exactly the same as the percentage change in price. Think about your own spending. Which products would you consider elastic, and which ones inelastic? Take 20 seconds to think about examples around you. Remember, elasticity is not fixed for a good. It can change with different price levels or over time. Let's explore how price elasticity of demand is not a fixed number along the demand curve. Look at this graph from Figure 2.19 that displays a linear downward sloping demand curve. At the top, where price is at its highest intercept, the elasticity is infinite. This means even the smallest price change could lead to huge changes in demand. This is called perfectly elastic demand. As you move down the curve, elasticity decreases. At the midpoint, elasticity equals exactly 1, representing unitary elastic demand. The percentage changes in quantity demanded and price are the same here. Finally, at the very bottom where quantity is maximum and price 0, elasticity becomes 0. Perfectly inelastic demand, where quantity demanded doesn't change with price. Why is this important? Because it tells us that consumer responsiveness varies at different price and quantity points. Pricing strategies and tax policies must consider this variation for effectiveness. Pause now and think. What does it mean for businesses when demand is perfectly elastic at high prices and perfectly inelastic at low prices? Take 20 seconds. Now, let's look at a fascinating way to measure elasticity on a demand curve geometrically, rather than purely algebraically. This method uses the lengths of segments between points on a linear demand curve to calculate the elasticity at a particular point. In the graph shown, the demand curve BA is plotted against the price axis OB and quantity axis OA. Suppose at the price P0, the quantity demanded is Q0. Small changes move price from P0 to P1 and quantity from Q0 to Q1. Using the properties of similar triangles BP0D and OBA, and ratios of segments DA and DB on the demand curve, we find that price elasticity of demand at that point equals the ratio DA divided by DB. This geometric approach provides an intuitive and visual understanding of elasticity. You don't have to rely purely on formulas, but can observe the graph directly. Think about what this geometric insight implies for analyzing market demand curves drawn from real data. Pause for 20 seconds to digest this visual explanation. Let's analyze this demand curve graph to deepen our understanding of how price and quantity demanded interact. The vertical axis from O to B represents price, while the horizontal axis from O to A represents quantity demanded. The downward sloping line BA is the demand curve, illustrating the fundamental law of demand. As prices fall, consumers buy more, and as prices rise, consumers buy less. Points P1 and Q1 correspond to a higher price and smaller quantity demanded. while P0 and Q0 represent a lower price and larger quantity demanded. The rectangles OBCE and OACD represent total revenue at these different price quantity combinations. Total revenue is simply price times quantity. When price drops from P1 to P0, quantity demanded rises from Q1 to Q0, and the overall effect on revenue depends on elasticity. Understanding this graph helps businesses predict how changes in prices affect revenue and informs government policies on taxes and subsidies. Take a few moments to reflect. If price falls, what happens to total revenue when demand is elastic? And what if demand is inelastic? Pause for 25 seconds. Now, we explore 3 special demand curves that demonstrate constant elasticity throughout their length, each representing unique consumer behavior. Panel A shows a vertical demand curve where quantity demanded remains constant at Q, no matter what the price is. Here, elasticity is 0, indicating perfectly inelastic demand. Think of life-saving medicines where consumers buy the same amount irrespective of price. Panel B illustrates a horizontal demand curve where price remains fixed at P. Any slight increase causes quantity demanded to drop to 0. Perfect elasticity, with elasticity equal to infinity. This is typical for goods with perfect substitutes, where consumers switch immediately if price changes. Panel C depicts a more realistic rectangular hyperbola, where the demand curve shows unitary elasticity, meaning the percentage change in quantity is always exactly the same as that in price. Understanding these curves assists policymakers and businesses in predicting consumption patterns and tailoring pricing or subsidy decisions. Pause now and consider which goods you know might fit each type of demand curve. Take 25 seconds to reflect. Let's recap all the important ideas we've covered about elasticity of demand. At its core, price elasticity tells us how much the quantity demanded for a good responds when its price changes. We have elastic demand, where consumers are highly responsive to price changes, with elasticity greater than 1. Inelastic demand means consumers are less responsive, elasticity less than 1. And unitary elasticity is the middle ground with elasticity equal to 1. It's fascinating how elasticity isn't a fixed number, but changes along a demand curve. We also saw special cases with constant elasticity, perfect inelasticity, perfect elasticity, and unitary elasticity, each shown by a different demand curve shape. Why do these concepts matter? Because governments deciding how to impose taxes or businesses deciding pricing policies rely heavily on knowing elasticity. For example, taxing goods with inelastic demand tends to raise revenue without large decreases in consumption, important for funding public goods. Let's pause for a final thought. How do you see elasticity influencing the prices you pay every day, like on food, clothes, or entertainment? Take 20 seconds to reflect.